Dear student, warm welcome to NPTEL Phase 2 program video course on Geosynthetics Engineering in theory and practice. My name is Professor J. N. Mandal, Department of Civil Engineering, Indian Institute of Technology, Bombay, Mumbai, India. Now this is module 13, lecture number 58, designing with geofoam. This is the rigid plastic foam were developed in 1950 and it has exclusively used for the cushion packaging as well as thermal insulation. And then lot of research work have been began in 1988 and lot of application also have started around the world in sometimes in 1960 and 1970 onwards. So it has a several alternative term. It can be called as a geo block or as a geo inclusion or geo board, also the geo material and also the geo solid. So this is the what is called the geofoam block, and you can construct the embankment on the soft soil, and this is alternative to the filling material, and then top of the geofoam you are providing with the pavement overlay, and in the side slope you can fill up with the covered soil and then grass can grow. So it looks very greenery. Also you can place the one layer of the geotextile material in between the geofoam and the subgrade soil, which also separate the geofoam and the subgrade soil. Now compression of conventional geofoam embankment as per BASF 1965, you can see here in the traditional how the increase in the surcharge pressure. If the pressure here is the sigma 0, so due to the application of the load and there will be a increase of the surcharge pressure. That means this sigma 1 will be greater than the sigma 0. So what we do, we provide with the some filling material to construct an embankment. On the other hand, now if we introduce this geofoam material, alternative to the conventional filling material, as the geofoam material is a superlight material, and we are introducing this geofoam material here, and on the top of the geofoam this is the filling material and whose depth about the Z1, and here the thickness of the geofoam material is Z2 and sigma 0 is the stress, and when apply load here can see this is the sigma 1 development of the stress at this level. So here that sigma 1 is equal to sigma 0. In the conventional method that there is an increase of the stress in surface pressure, that sigma 1 greater than 0. But when you are introducing the superlight material like geofoam, then there is no increase of the surface pressure. So here the sigma 1 is equal to sigma 0, and this also the Z1 equal to that Z of 2. So from this example it is observed that the geofoam material is effective, and geofoam material does not reflect any increase of the surface pressure with respect to the conventional method. This another example. So geofoam which you can construct a retaining wall. So if this is the wall, retaining wall, so you don't need to fill up with any other kind of the filling material. You can place only this geofoam block, because this lateral pressure will drastically reduce due to the deployment of the geofoam material. So we observe that it can be used for the construction of the embankment of the subsoil, where the stress can be minimized, and also in case of the retaining wall, the lateral pressure can reduce drastically. So what is the geofoam material? So most of the time we use this thermocol for the packaging. So we even then take a cup of tea or the coffee using this material what is called thermocol, and this thermocol is nothing but in geotechnical engineering called the geofoam. So this geofoam also has been included under the family of the geosynthetics. As per STMD 4439, the geofoam can be defined as the block or the planar rigid cellular foam polymeric used in geotechnical engineering application. In textile term, the geofoam is called as expanded polystyrene or extruded polyester. The geofoam is a cellular plastic material. We say it a thermocol used for the packaging the electronic goods, making cup, container to drink coffee or tea and others. The geofoam is a superlight material which is available in the form of block or cellular honeycomb form. It provides easy of handling. It is an emerging geomaterial. The size of the block molded geofoam is about 600 millimeter into 1200 millimeter into 2400 millimeter. The block size can vary from country to country. The other minimized sizes can be made by cutting and trimming at site. Weight of the block varies from 11 kg per meter cube to 40 kg per meter cube. Its density is very less, about 100 times less compared to the conventional fill material in geotechnical engineering. Geofoam have been used in many structures around the world for the last 45 years. The lifetime of the geofoam is about 70 to 100 years. So here you can see that full size of the EPS block. This EPS is called expanded polystyrene in textile term. In geotechnical term we call the geofoam. So this is the full size of the block in temporary storage after the molding. So you can cut the block as per your requirement at the project site. You can have for various densities and various thickness. So these are the block molded geofoam or expanded polystyrene material. So this geofoam material act as a separation function, and this geofoam also can be laminated with the geotextile material, where the geotextile material is act as a drainage. So when it is required the separation and the drainage for any project, then you can laminate the geotextile material with the geofoam itself. Apart from that, this geofoam material itself will act as a drainage. So this is the geofoam beads, and from these beads this drainage material has been manufactured. So you can see this is the number of the balls and there is a pore size, so it is easy to water can percolate through this kind of the geo drainage material, and this is the geofoam or expanded polystyrene material. So this geofoam can be laminated with this geofoam drainage material. This geofoam material will act as a separation function. On the other hand, this geofoam black or white combination will act as a drainage. So for any project where you require both the separation and drainage, so you can laminate this drainage material with the geofoam material. So this is the size of the block is generally this available. I have told you this dimension of the block, and this expanded polystyrene block is weight about 36 kg and 2% can easily handle, and it is a very super light material. So this also you can see another geofoam material. So here, apart from the, because this geofoam material also you can have in different configuration. You can make it this geofoam in the square form. You can see this is the geofoam, and you can make in the square form of this geofoam material. Here is the square form geofoam material. So what you can reduce the size of the geofoam. From the solid geofoam you can cut and can make this square form. This also is very much necessary in geotechnical engineering job. You can fill up with the filling material, and also this geofoam material can provide this very confining also effect. You can have it in the square form as well as you can have also in the hexagonal form. So this is one which you can see in the hexagonal form. So lot of research work is going on in this institute, that using the different configuration of the geofoam material, either it may be the solid block, or it may be the square form, or it may be the hexagonal form. And also it has been also optimized that what size and shape and configuration will be the best for the use in the practical field. So what should be their dimension, and whether the square or the hexagonal gives the best result. So this is square geofoam geocell, as I showed you, and this is honeycomb geofoam or the hexagonal geofoam shape. So Norway Public Road Administration 1972 used geofoam as a lightweight material for the construction of road embankment. Lot of research work have been carried out on the geofoam or expanded polystyrene by various researchers, that is Thornspesset et al. 1995, Aboe 1987, Duskop 1991, Horvath 1992, Stark et al. 2004, Horvath 1997, Mandal 1998, Nibalkar 1999, Hazarika 2006, and Wagadabe 2006, Mandal and Nibalkar 2004, and Horvath 1995. It was reported that temperature of the geofoam should not exceed of 95 degree centigrade. Geofoam has been exclusively used in Belgium, Canada, Finland, France, Germany, Japan, the Netherlands, Norway, Sweden, United Kingdom, and USA, though its use in India is in infant stage. One of the reasons may be that many engineers do not aware of this new geomaterial, and number two, there is a possibility of the cost of the geofoam material itself. But if you look in terms of the overall cost of the project, then this kind of system is more economical and advantage, because you don't need almost any equipment. You don't need any compaction equipment. You don't need so much manpower. You don't need very good quality or material transport from one side to the other side. So if you look in terms of the overall cost of the project, then geofoam material is the best, and this is very fast construction, because this is a super light material. It is easy to install, easy to construct, and also it resists a very good earthquake related problem. Farendun and the above in 1994 reported that geofoam have been used over 150 projects in Norway. Bearing capacity of the clay or silt can be considered equivalent to compressive strength of expanded polystyrene or EPS, and that is 100 kilopascal. Arellano and Stark 2009 recommended to provide lower density of geofoam at lower portion and higher density of the geofoam at upper portion of the roadway, a magnet for economical design solution. So it has very nice to place the geofoam material with proper density, because this geofoam material are available at various density. It may have from 11 to 40 kilonewton per meter cube, At the same time, the placement of the geoform also very important. You can change the density of the geoform. So, lower density you can place, and also high density you can place at the upper portion, and lower density can be placed on the lower portion. That way you can make more economical and design, because the cost of the geoform material also depend on the density of the geoform material itself. So, you can minimize the cost by considering the proper kind of the density of the geoform. And some research work also have been completed in this institute using these different types of the geoform and different densities. Either it has been placed on the lower portion of the embankment or the higher portion of the embankment, because you have to observe which one provide the most safe and suitable design. Wang and Nagasue 2011 reported modified test method to determine California bearing ratio, that is CBR, resilience modulus, and modulus subgrade reaction of geoform. Athek in 1998 reported that cost related to damage because of soiling is double of the cost related to the damage from earthquake, flood, tornadoes and hurricane. Since the early 1990s, the geoform has been a generic term for any synthetic geomaterial created in an expansion process using a gas, that is blowing agent, resulting in a texture of numerous closed cell. Geoform is not just one material or product, but a very diverse family of many different kinds of material. So, this is development of the geoform in geosynthetics family. Faraday 2010, this is a rigid plastic foam, it is developed in 1950, and this application of the geoform in geotechnical engineering, it began in 1960, and this can be say that geoblock, geoboard, geosolid, geoinclusion, also you can say geomaterial. So, these are the geosynthetics family, this geoform. This is Horvath in 1991, and it may be the expanded polystyrene material, which is lightweight material and compressible inclusion. Because lightweight material, you can construct the embankment as a filling material, and also it is a compression inclusion because you can provide at the back of the retaining wall, which will act as a compression inclusion, and the lateral pressure can dramatically reduce. Whereas extruded polystyrene material, this is a thermal insulation and also the drainage. So, it is required some time to store the material, and we use some conventional system with the gravel stone, etc. So, alternative to that, you can use the geoform material and you can save the power. So, I will give you later one example related with the thermal insulation, also that the problem related with the embankment construction on the subsoil using the lightweight fill material, and as well as for the retaining wall where you can use the geoform material. And geoform material itself can be used as a retaining wall. So here you can see that expanded polystyrene, it is available in the form of powder. You can see here almost like a powder, and then you can make a beads. So you use something bag, EPS beads bag. So this is the kind of the beads which is produced from the EPS powder, and these beads also can be used for the drainage. This EPS block also is for the other application, and from this EPS block beads you can produce the geofoam. So this is the formation stage of the geofoam block. And if you take a scanning electronics microscope, that is ACM picture of the geofoam beads, you can see how it looks, this beads, and you can see that what is the opening of the beads material. And this is a modified geofoam has been prepared by mixing the geofoam beads, fly ash, cement, water in proper protection. So this is the work has been carried out in this institute, and this is the mixed geofoam beads, fly ash and the cement and water in proper proportion, and this is the prepared the modified geofoam block, or you can say new geo material. Because we are using here the waste material, that means fly ash, and as well as that if we find that geofoam material or expanded polystyrene material is expensive, so alternative to that geofoam material, so you can make use of the new generation geo material, so which is also very light and which also can provide very good compression effect. So I will later focus on this related material. Now classification of the geofoam priority 2010. This is the geofoam. It may be cementitious or it may be cellular glass. This is a polymer plastic. It may be polyethylene or polyurethane, or it is excluded polystyrene XPS, or the polystyrene and blend, that is PEPS, or expanded polystyrene, which you call EPS in the textile term. So approximately 100 times lighter than most of the soil and 20 to 30 times other lightweight fill material. So here we are focusing EPS geofoam manufacturing process after BS 1995. So we have observed the beads. These beads is to be inserted here, and then the steam are provided from this top, and this will expanding, when you beads will be expanding, and then it passes through the air, and then it can be storage. There is steam storage, and then this is the steam and this is the molding. So ultimately you can make a mold either in the rectangular or in the square, and then you have to keep it for the curing. So then ultimately you can have the different mold or the block either in the cubical form or in the rectangular form in the solid. Okay, and this geofoam material has various density. So in terms of the application in civil engineering, so geofoam can effectively be used in various engineering application: embankment and the pavement, retaining wall and abutment, any road widening, a railway, foundation problem, side, hill, fill, landscape, dike, bumps, below ground wall of structure, tunnel and buried pipe and tunnel, clay liner, flood control lifts, parking, clay heap protection, sound barrier, landfill and gas venting. I will show you some of the application, what and how can use of it. What we do in conventional method, we got good quality of the granular material are used as a backfill behind the retaining structure. Sometimes the material are costly and as well as it is expensive. So inclusion of the geofoam reduce the lateral pressure dramatically. You can see here, this is the retaining wall and you are providing with some drainage material here. It's a granular material you are using and we provide with the traditional backfill material. Okay, this is retaining wall and the back of the retaining wall you have to provide with the drainage material and good quality of the material you have to provide for drainage and then you have to be provide with the all traditional material. Alternative to this, you can use simply geofoam material like this. So you don't need any compaction. So simply you can place this block at the back of the retaining wall. So because this material is very super light material, its density is 100 times less than the soil, so it will provide the lateral pressure and that lateral pressure reduce drastically for the inclusion of the geofoam material. So here the geofoam material as an alternative backfill material behind the retaining wall. Now if you want to construct that embankment, most of the cases you know traditional method, this is foundation and you require good quantity of the muram, and in Bombay this muram is very expensive, it is like a gold, sometimes not available, and in the conventional method you provide this as a filling material, soil as a filling material. But on the other hand you need the compaction. On the other hand, alternative to this as a filling material, so you can simply place this geofoam block. So here geofoam material will act as a filling material and then you can put on the top of this, you can provide with the asphalt overlay or you can concretize also, and at the side of the embankment slope you can fill up with the soil and the grass can grow, so it is environmental friendly, it will give a greener structure. You can place also one layer of the geocomposite material in between the foundation soil and the geofoam block, which will act as a separation and also act as a drainage material. So this is construction using the geofoam material is very fast and also economical. Here some major application for the geofoam. This is a concrete cover and this is the EPS block or expanded polystyrene block or the geofoam material, and this is the pavement and this is the backfill soil. So here geofoam material also is act as a retaining wall. So you don't need to construct a reinforced concrete retaining wall. So here you can see this is the retaining wall and here geofoam block has been used, and also there is a drainage, it can be drained it out. Sometimes if you in this kind of the situation, and you can place, because it's kind of the slope, so you can place the geoform material and you can construct the house, and also at the back you can see you can make a road, the vehicle can pass through this area, so there is no problem. So here is the placement of the geoform material as a backfill material behind the reinforced concrete retaining wall. Here is the retaining wall, and the back of this you can see that geoform block has been forced. This is a small scale model. Now this is the placement of geoform as a drainage behind the reinforced concrete retaining wall. So you can provide the drainage material. I showed you that what will be the drainage material. So you can simply provide also the drainage material and then the geoform. So this geoform which will act as a drainage, and as well as it will act as a compression inclusion. So here the placement of the geoform as a compressible inclusion behind the reinforced concrete wall. So if this is a reinforced concrete wall, you are providing the some thickness of the geoform material. Here you can see if this is the reinforced soil, this is the wall, and at the back of this you are providing a certain thickness of the geoform material, this white color, and then you are providing the backfill material. Now this thickness of the geoform material, it varies also that what kind of density you wanted to use, and what should be exact thickness of the geoform material. So you don't require very high or very thick geoform material. So you can design and will be able to say that what kind of the thickness of geoform material you should place on the back of the retaining wall. So here this geoform material will act as a compression inclusion and also is reduce the lateral pressure. Lot of research work have been carried out here. I will show you with one example that with the thickness of the geoform material, how this the lateral pressure can reduced, and it depends upon the density of the geoform material, and also it depends upon the thickness of the geoform material, and also how you can design that what should be the thickness of the geoform material. We will later discuss more about this problem. Now apart from this, if this is the wall and this is the geoform, you can place a number of the layer of the reinforcement. If the situation arises like this, so you can see here, this is the wall and this is the geoform, and number of the reinforcement layer has been included. This is multi-layer of the reinforcement. So here the geoform will act as a compression inclusion, and here the reinforcement will act to resist the tension stress, and then you can wall can be much more less stable, and the lateral pressure also will reduce. So here is the geoform application retaining wall for extension of the existing pavement. So this is one area where this is the retaining wall existing and this is the slope, and again this is the road. This is some area in Pune, and this road is to be expanded up to this. So there are defined types of the technique. Someone can feel that he can go for the soil nailing this, that, but you can use this geoform system and it will be the very fast. So this system you can provide that extension of the existing the pavement. So you can make use of this road by the inclusion of the geofoam material. Now here the application of geofoam behind the bridge abutment after Stark ETL 2004, where this is the weight of the pavement system, also that what we call dead load of the geofoam. If there is also any seismic aspect, that also you can take into consideration, also dead load of the soil, and also there will be the active earth pressure. So all this has been also considered for the design. Now this geofoam material also act as a noise barrier. So here it is the geofoam. You can construct the wall of the geofoam wall, and you can keep with the barrier here. You can see here. So you can use this geofoam material as a noise barrier, and it is not so expensive because you need the very thin thickness of the geofoam material. It is lighter material, and also some of the country use the RE wall or the geogrid reinforced wall as a noise barrier, and sometimes some other alternative system they provide, but this is the more suitable, attractive, and also easy to construct, and it is much more economical. So this kind of the system can be adapted for a noise barrier. So this is geofoam as a filling material behind the pavement. I am showing you here that how the pavement can be constructed with the geofoam. This is the embankment made of geofoam as a filling material. Here is the geofoam, then how you can construct this embankment using the geofoam. Here if you require the widening of the road. So when you want to widening of the road with this slope, so you simply you can place this geofoam material and you can extend the road, and then on the slope you fill up with the soil, and then grass will grow. Or if this embankment you want to make with the geofoam material, even then you provided the slope not the vertical, then also you can see that vehicle can passes through this area safety, and so you can construct a house on the top of this road. Here the geofoam beneath the slab or the beam at the foundation after Faridweight ETL 1987. So here is the beam, here is the concrete beam, and here is the geofoam material. So this geofoam beneath the slab or the beam at the foundation will help you to reduce the pressure. And here is the slope slide field of geofoam. Any slopes in this area, you can see like this. So you can place the geofoam material and you can construct the slope side field with the deployment of geofoam. Some geofoam application in the hilly terrain, it is very difficult sometimes to construct, but you can simply place the geofoam material and concretizing, so you can construct the road. Here is the some schematic view of different density of the geofoam used for the road construction. So here is the geofoam, then the sand, then the crushed machinery, and then asphalt concrete, and then you can provide with a certain slope and 2%. So you can construct the road. Like you can see on the right hand side, this is small scale model. where it has been used the geofoam and the crushed sand and the crushed stone at different density. So here is the geofoam beneath the bridge abutment after Florida and Abade in 1996. You can see the water is passing here and in the bridge abutment where in this slope the geofoam has been used, and this is the bridge, huge bridge. Its height may be about 4 to 4.5 meter and this expansion is about maybe 36 meter. Okay, this is one of the case history in Netherlands. And also geofoam we can provide above the canal. Suppose if there is a canal and you construct the road on the top of this canal. So it is very difficult. So you can introduce this geofoam material, because if this is the canal, this is the concrete canal and water is passing through that and you wanted to construct, this is the place and you wanted to construct this road or embankment. So you can simply fill up this gap and you can construct this embankment. So some geofoam at the basement of the thermal insulation. So here you can see that concrete, this is the geofoam, this material, and here is the drainage. So here you can see, here it will act as a thermal insulation. So when there is a difference in the temperature inside the room and the outside the room, okay, there will be difference in the temperature. So you wanted to keep the room in cool. So you can provide with the geofoam material. Then you can see the difference in the temperature, where this geofoam material will act as a thermal insulation. So I can show you with later on with some example where the geofoam material has been used as a thermal insulation either for the food protection. So you have to keep the food in a cool temperature for the safety. Similarly for the house, you wanted to keep the house cool. So in that case, instead of the conventional material, that is granular material, you can introduce this geofoam material and you can find that room is cool or the storage is cool, so your food is also safety. Now most of the time you can see that there is a formation of the crack of the building when particularly rest on the swelling soil. So geofoam here as a compressible inclusion beneath a grade beam or structural slab. So this is the structural slab, this is the deep foundation, and this is the graded beams down. On the base of this beam you can provide the geofoam here. Here you can see this is the geofoam and this is the beam or the slab. Because for the swelling soil there is a upward thrust. So this upward thrust can be minimized by the introduction of the geofoam material, so it will not affect the building, and this you can prevent the building from the cracking. If you go for conventional method, then there is a formation of the crack, but here because due to the geofoam material which will act as a compression inclusion, so this building will not be any problem, there should not be any formation of the crack. Now here that geofoam as a compressible inclusion above the pipe or the culvert. So sometimes you can see that any pipeline or pipe passes below the ground surface and you require to fill up with the soil up to certain depth. So you can minimize the depth by the inclusion of the geofoam material, where geofoam material will act as a compression inclusion. Some research work also going on in this institute where that pipe and also geofoam material has been used, and you find that it is very effective. You do not require very hard depth with the filling with the material above the pipe. So you can minimize the either the depth of the excavation or fill up with the soil. So here you can see this model. This is the pipe and this is the geofoam. So initially if we find that if we provide it at a certain depth and if we apply the load and there is a possibility for bending of the pipe, so you need to increase the depth of the filling material. So alternatively, if we can provide with the geofoam material either in the semicircular form or in the rectangular form, then because for its compressible inclusion, then stress cannot be distributed to the pipe, then pipe also will be the safety due to the application of the load. You can see some of the very interesting application. The geofoam has a compressible inclusion for underpass after Freddy at ETL 1997. So you don't need just to place this geofoam material and in the top is the pavement. So vehicle can pass through, the people can easily pass through this area. You can see some also the geofoam for compressible inclusion for the railway. So this is the railway. So on the top of the railway also you can provide with the geofoam material here. You can place the geofoam, you can construct this railway here, and then on the top of this you can fill up with the geofoam material and then pavement can be constructed. So one way the rail can pass below the ground and also the car can pass on the road. So this is kind of the geofoam will act as a compression inclusion for railway. This is some of the example. This is the geofoam where you can construct the retaining wall, and this is the geofoam material. This is like a tunnel or where geofoam has been used, and this is how you can see the geofoam has been placed. Also here is along the slope that how you can use the geofoam material. So this is the side slope where you can place the geofoam and then you fill up with the soil, because sometimes that if there is a petrol, then geofoam will be very effective. So you can provide with the layer of the geofoam material or polyethylene material which can be protected, and on the top of the polymer material you can provide with the soil and then grass can grow. And also bridge ram construction also with the geofoam. You can see here how the geofoam has been used and it has been checked after 25 years in service. So there is no deformation of the geofoam and there is no damage of the geofoam material. So we conclude that here that geofoam has a lot of potential application and it is very much needed in India and some also developing country, that where we can make use of the geofoam material, and we have a plenty of the geofoam material in India. So we can make it more economical and stable structure, and this construction time is very, very less. So with this I finish my lecture today. Let us hear from you. Any question? Thanks for listening.